Professor Carlos Plain from Durham School said that he spent his career trying to piece together how the cosmos works. Now, stuff is happening that's making everyone rethink things. He welcomes it since that's how science gets better. The James Webb Space Telescope is making us question a lot of ideas about the cosmos that we thought were solid for decades. A new image showed we were wrong about some stuff in astrophysics. The telescope, which was supposed to look at the center of galaxies, is giving us surprises. These could mean we need a whole new way of seeing the universe. Not all scientists are worried about this. A lot of them are happy to change, admitting that the old ideas had problems. We should have been wondering about the quick speed of the cosmos for a while now. But most people stuck with the old ways of thinking. The cosmic microwave background, or CMB, is the first light we could see from about 380,000 years after the start of the cosmos. When it got cold enough for electrons and protons to become hydrogen atoms, the cosmos let light through. This was first spotted in 1964 by Arno Penzias and Robert Wilson, who were American scientists. They were fixing up some fancy radio tech and heard a constant noise coming from everywhere. The find seemed to back up the Big Bang theory. Penzias and Wilson received a Nobel Prize, and this was a big deal for astronomy. The CMB lets us peek at the early cosmos, and little temp changes give us clues about what it was like then. But what the JWST saw gives us an even better view. The CMB has been good for figuring out things about the cosmos, like how fast it's growing. Back in the late 1920s, Edwin Hubble saw something similar. He saw that galaxies far away were moving away from us, and the farther they were, the faster they went. We call that Hubble's law now. His results weren't as exact as what we have now, but they changed everything. After finding the CMB, astronomers changed the rate of expansion of the cosmos, figuring it was slower than what Hubble thought. Later, using type Ia supernovae as measuring tools, scientists received better results. But there were still differences, and this measuring problem has been around since the 90s. Scientists started wondering if the problem was with the CMB data or if we needed to rethink some basic physics. This problem is called the S8 thing, or Hubble tension, and it means we might not have the right understanding of the cosmos. Now that the James Webb Space Telescope is working well, it's giving us new info that could fix these problems. Some of the galaxies it saw are so old that they might have formed before the Big Bang, which messes up the theories we have. Astronomy today is dealing with what some people call the biggest crisis in modern cosmology. We're looking at our ideas about how the cosmos expands and started all over again. The new find is like saying, hey, look at this. The cosmos is way different than we thought. The S8 tension is like a warning sign to astronomers still sticking to the old ideas. We're facing the limits of what we know about the cosmos. This makes some scientists bummed. To fix it, we need to know how science works. Theoretical physicists use math, data, and logic to figure things out. They get better by spotting trends, checking theories, and running simulations in their heads. A theory itself is like a work in progress, not the final say. We see things through telescopes, sound waves, radio waves, and neutrino and gravitational wave tools. The James Webb Telescope lets researchers split up old light into colors to look at it closely. It shows what was in galaxies billions of years ago, like what they looked like and what stars were in them. But the telescope can't do everything. For example, it might miss galaxies or black holes that look bright because of gravitational lensing. We've gotten better at understanding things by checking out lots of ideas and trashing the bad ones. The new stuff from JWST gives us proof that we can swap out the old ideas for new ones. Scientists are trying to make sense of this, and making new theories is hard. This stuff is shaking up physics and making some people nervous. The things that shape our world mostly come from Isaac Newton's work in the 1600s. For centuries, Newton's laws of motion and gravity were the base for knowing natural stuff. His equations are still good on Earth, but Albert Einstein changed them for space in the early 1900s. Einstein's special theory of relativity in 1905 changed how we thought about space and time, seeing that physical laws change with how fast you're going. His general theory of relativity in 1915 had fancy equations explaining how big stuff like stars and galaxies bend spacetime. Even though these theories did well, Einstein knew they had limits and wanted one thing that could tie all the basic forces together. We still don't have that today. It's interesting to ask when we might have gone wrong. Myoku, a big U.S. astrophysicist, said that fixing this could win someone a Nobel Prize. We need to ask if we've misunderstood cosmic patterns or if our measuring tools are at fault. Dark matter and dark energy are big pieces of this cosmic puzzle. People think they make up almost 95% of everything in the cosmos. But we haven't seen them or for sure proven they're there. They might not exist or they might act in ways we don't get yet. One theory is that dark matter has changed over time, which could give us new info about gravity, linked to mass and spacetime bending. Gravity hasn't always behaved as we thought. Even though Einstein's idea of curved spacetime has been proven a bunch, gravity might have hidden things, or there's a force we don't know about affecting cosmic happenings. Over the years, some numbers in astrophysics have been accepted because they always worked. But new proof shows that even small changes in these numbers could change everything we know, and dark energy may not be necessary. It's also able we've misjudged how light works, which means we're not measuring distances right and the age of stuff in space is off. Maybe we're wrong about how the cosmos started. Maybe we've gotten the CMB wrong. Or maybe the cosmos didn't start with one big explosion, which would make the Big Bang Theory wrong. Even small tech problems with tools like the Webb telescope can't be ruled out. Some experts say that broken stuff, wrong readings, or mistakes in seeing things could always affect what we think. This constant rechecking of space science is key. It is a sign our willingness to change as new find becomes real. The find from JWST is also a goal for the human race as we reach for universal truths. As we understand this data, we have to see what it means on a bigger scale and modify our theories to match. Updating models when things don't fit is scary, but necessary. These problems give us the chance to make real progress in our understanding. The goal of cosmology is to find out how the cosmos started, how it changes, and where it's going. But as new evidence arrives, we have to check and fix our ideas. Dark matter and dark energy are big problems today. Dark matter, which we can't see or interact with, was thought that it had more mass than what we can see. Dark energy was the new reason for accelerating speed of cosmic expansion. Yet both are shrouded in mystery. Even with lots of tests, we still don't have direct proof of either object, and pushing some to suggest different physical laws. After we found the CMB, astronomers reworked the numbers on how fast the universe is growing and realized it was slower than Hubble thought. Later on, using type Ia supernovas as markers, scientists got even better numbers. But there were still some differences, and people have known about this since the 90s. Scientists started wondering if the problem was with the CMB data or if we needed to rethink some basic physics. This puzzle, known as the S8 thing or Hubble tension, suggests our current picture of the universe might be missing something. Now that the James Webb Space Telescope is up and running, it's giving us crazy good information that could help us solve these puzzles. Some of the galaxies it's found are so old that they might have formed before the Big Bang, which would cause big problems for the theories we have now. Right now, astronomy is facing what a lot of people are calling the biggest crisis in modern cosmology. We're taking a second look at our ideas about how the universe started and how it's growing. The new stuff we're seeing suggests the universe is way different than we thought. The S8 tension is a warning to astronomers who are still sticking to old ideas. We're running into the limits of what we know about the universe. This has made some scientists feel down. To deal with it, we have to understand how science actually works. Theoretical physicists use math, data, and logic to come up with ideas. They get better by spotting trends, testing theories, and running simulations in their heads. A theory is just something we're always trying to make better, not a final answer. We learn from telescope pictures, sound waves, radio waves, and stuff from neutrino and gravitational wave instruments. The James Webb Telescope lets scientists break down ancient light into different colors to study it closely. It shows us what galaxies looked like billions of years ago, including what they were made of. But the telescope has limits. For example, it might miss galaxies or black holes that are shining really brightly because of gravity. We've gotten this far by looking at a ton of possibilities and throwing out the ones that don't hold up. The recent stuff from JWST gives us important evidence that could replace old beliefs with new ideas. Scientists are wrestling with these crazy results, which are so unexpected that it's hard to come up with new theories. These ideas are shaking up physics in a big way, which is making some people uncomfortable. The laws that shape our reality mostly come from Isaac Newton's work in the 1600s. For centuries, Newton's laws of motion and gravity were the basis for explaining how nature works. His stuff still works on Earth, but Albert Einstein expanded on it in the early 1900s for use in space. Einstein's special theory of relativity, which he came up with in 1905, changed how we think about space and time by showing that physical laws change depending on how fast you're moving. His general theory of relativity from 1915 gave us complicated formulas for explaining how massive things like stars and galaxies mess with space and time. Even though these theories were successful, Einstein knew they had limits and wanted to find one idea that would tie all the basic forces together. We still haven't found that theory yet. It's interesting to think about where we might have gone wrong. Mayoku, a big-shot astrophysicist in the US, has said that fixing this problem could win someone a Nobel Prize. We have to ask if we've misunderstood cosmic patterns or if the problem is with our instruments. Dark matter and dark energy are key parts of this mystery. We think they make up almost 95% of the universe, but we've never seen them directly or proven they exist. They might not be real, or they might be working in ways we don't understand yet. One idea we're looking at is that dark matter has changed over time, which could give us new info about gravity, which is tied to mass and spacetime warping. Gravity hasn't always acted predictably. Einstein's idea of curved spacetime has been proven a bunch of times, but it's possible that gravity has hidden features or that there's some force we don't know about messing with cosmic stuff. Over the years, we've accepted certain numbers in astrophysics because they've worked consistently. But new evidence is suggesting that even small changes in these numbers could change everything we know and might mean we don't need dark energy. It's also possible we've messed up how light works, which would give us wrong distance measurements and age estimates for things in space. Maybe we're wrong about how the universe started. Maybe we've misunderstood the CMB. Or maybe the universe didn't start with a single bang, which would throw the Big Bang theory into doubt. We can't even completely rule out small technical problems with instruments like the Webb telescope. Some experts argue that equipment failures, wrong readings, or mistakes in how we're seeing things could always mess with our conclusions. This constant reevaluation of space science is important. It shows we're willing to change as we get new information. The findings from JWST are more than just cool engineering. They're turning points in our effort to figure out the universe. As we look at this data, we have to think about what it all means and change our theories to match. Updating models when we see weird stuff isn't just something we have to do, it's helpful, even if it's a little unsettling. These contradictions give us a chance to make real progress. The point of cosmology is to figure out how the universe started, how it's changing, and where it's going. But as we get new evidence, we have to rethink and improve our ideas. Dark matter and dark energy are still the big questions in cosmology. Dark matter, which we can't see and doesn't react to light, was suggested to explain why galaxies act like they have more mass than we can see. Dark energy was brought up to explain why the universe is expanding faster and faster. But we still don't know much about either of them. Even after a lot of experiments, we still don't have solid proof of either one, which is making some people think we need completely new laws of physics. Trying to figure out dark stuff is hard because the universe is so huge. The CMB and other things give us hints, but we don't fully understand what they mean. This has led theorists to suggest everything from tweaked models to completely different laws of physics. Some ideas say dark matter is made of unknown particles, while others say dark energy might be a new basic force. Another big idea is cosmic inflation, which is the idea that the universe ballooned up super fast right after it was born, shaping what we see today. It fixes a lot of problems, but it also brings up new ones. Any data that goes against inflation might mean we have to completely rethink the early history of the universe. Could it even be that what we think is real is just a simulation? One last and important thing we're doing in space is looking for alien life. Finding exoplanets, which are planets around other stars, has opened up the chance of finding places that could support life. With powerful tools like JWST, scientists can now look at these planets for signs of life. Proving that life exists somewhere else would totally change how we see our place in the universe.